All right, so we were looking at the second way that we could do number 13 on our calculator. All right, so we had said you could go into second matrix and put each of your matrices, like put one in A and one in B, and then you could say A times B. All right, another way that you can do that, as long as you have an 84, not an 83, is you can go to Alpha Zoom and you have a dedicated matrix menu. So I could tell it that I want a 2 by 2. So you can see it's already set for 2 by 2 over there. So go up to 2 and hit enter. And you could change it. You know, if I want to change it to 5, I would go to 5 and hit enter. So I'm going to go to 2 and hit enter. And then I'm going to come down here and tell it OK. And it puts a blank 2 by 2 on my screen. So I'm going to put in that matrix 2, negative 1, 0, 4, but don't hit 2, enter, hit 2, and then your right arrow key to move over. So 2, negative 1, 0, 4, and then I'm going to multiply that by the other 2 by 2. So again, I'm going to go to Alpha Zoom to get that matrix key. And again, I want the 2 by 2, so I'm going to go ahead and tell it OK. And I'll put that matrix in. So we had 3, 1, negative 1, 2. And so that gives me the same answer. So it does not matter whether you put it in A and B and tell it to multiply A times B, or if you use the button there on your screen, either one. Okay, so then for number 14, they ask me to find the inverse of that 3 by 3. So again, I can do that one of two ways. I can go to second matrix and go over to edit and tell it that I want a 3 by 3. And then I'm just going to put that matrix in. So all right, so it was 1, 2, 3, and then 0, 1, 4, and then 5, 6, 0. All right, so once I've got that in A, I'm going to quit out of that. So second mode is quitting me out of that. And then I'm going to go back to matrix and stay right there on names to get A, and then hit my inverse button. And you can see the inverse button lit up in red there on the screen. It's the x to the negative 1. And so there would be the inverse of my 3 by 3. The other way that you could do that, using that matrix menu, using the Alpha Zoom. So this time I'm going to tell it that I want a 3 by 3. So there's my 3, and I will go over. Whoops, should have hit enter. There we go. And we'll go over and hit enter. So that tells it it is a 3 by 3, and go down and tell it OK. And it puts the blank 3 by 3 on there. So I'll just put that matrix in that we just had, and again hit my inverse button. And you can see we're going to get the same answer either way. If you have a preference, I don't care which way you do it, I just like for you to see options. Okay, so let's look at number 15. So for number 15, they gave me 3 times this matrix minus 2 times this matrix. Now, you absolutely could do this on your calculator, but it is so much faster to do by hand. Literally, this is just scalar multiplication. So 3 times 1 is 3, 3 times negative 3 is negative 9, 3 times 6 is 18, 3 times 2 is 6, minus, and then we're going to say 2 times 4 is 8, 2 times negative 1 is negative 2, 2 times 3 is 6, 2 times 2 is 4. And now we're subtracting. So 3 minus 8 is negative 5, 9 minus negative 2 is negative 7, 18 minus 6 is 12, and 6 minus 4 is 2. And I'm done. And I would still be typing that into my calculator if I were doing it on the calculator. If you want to go put this in matrix A and you want to put this in matrix B and then tell your calculator 3A minus 2B, that's perfectly fine. Or if you want to use that Alpha Zoom menu to type these in, you can. But again, I think that one's faster and easier to do by hand. 16, on the other hand, definitely not faster and easier to do by hand. I mean, I worked it out by hand down here, and it's a mess. Whereas if I put it in my calculator, it's this itty bitty bit of work right here. So I definitely want to do this one on my calculator. So for this one, we've got a matrix, I'm going to call it A, times X is equal to another matrix, I'm going to call it B. Now to get rid of A, we're going to multiply both sides by the inverse. So when I do that, A goes away and I get X is equal to the inverse times B. So all I need to do is put this in for matrix A, put this in for matrix B, and then I'm just going to say A inverse times B. All right, so let's go do that on the calculator. So again, I'm going to go to my matrix menu, and I'm going to go over to edit, and I'm going to edit matrix A to be a 2 by 2, and I'm going to put in that first one that we had, 1, 2, 3, 4. All right, quit out of that, and I'll go back to matrix, and this time I'll go edit matrix B. And that one was 4, 4, 10, 8. So a 2 by 2, 4, 4, 10, 8. All right, so I'm going to quit out of that and go back to tell it I want it to take A inverse times B. So again, we did second matrix, stayed in the names column to pull A. Then we hit our inverse button, x to the negative 1. We hit our multiplication button. And then second matrix, we stayed in the names column and went down to number 2 to get B. All right? And so there is that inverse. That one is definitely so much simpler to do on the calculator than to have to do all of this work down here by hand. Okay, then our last one, number 17, is an easy problem, but they're intentionally trying to trick me. So if you look at the original problem on the sample test, it was 4x plus 2y is equal to 1. They want you to come over here and put 4, 2, 1. If you are missing a term, you have to fill a 0 in for it. So we had 4x plus 2y. We need to fill in the 0z term. All right? The next one was negative 3z plus x, and the y term was missing, and they weren't in the right order. So you have got to write these as x, y, z, and if anything's missing, put a 0 in for it. So we had 1x, we didn't have any y's, and then we had minus 3z was equal to 6. And then for the last one, they just gave us y minus z equals negative 4. So again, we need to put a 0 in for the missing term, so 0x plus y minus z is equal to negative 4. So I would strongly encourage you to rewrite that system first and then pull out your augmented matrix. So it would be 4, 2, 0, 1, 1, 0, negative 3, 6, 0, 1, negative 1, negative 4. So that's where we're getting our augmented matrix right here.